All right. So first of all, I would like to basically share with you some information about your JavaFX and so on. So one of the important things about JavaFX is that many of you are actually doing your Java, and just a bit of information sharing. Let's see whether I have all the information here. Yeah, okay. So in terms of JavaFX Spring and AWT, I would like to basically show you the equivalence table first, right? So actually, if you use any of those, whether it's JavaFX, Java Spring, or Java AWT, you notice that there are components that are equivalent, especially in terms of the container model, right? So the top level container in our JavaFX is called a stage, whereas in Java Swing is called JFrame. Okay, anything that starts with J is Java Swing. And then your traditional AWT actually can use this type of notion also, but they would call it as a frame instead. Okay, and then your scene in our Java Swing is called JPanel, and that will be as a content pane, right? So it allows you to actually put multiple contents onto the pane. So this concept is actually being extended further to scene graph. That means a component hierarchy, right? So it's available in Java Swing and also in your JavaFX. In our AWT, of course, you can embed component within a component, right? But they don't actually call that as what we call as a component hierarchy, okay? And then all these are actually called component in AWT. But later you notice that in Java Swing and JavaFX, they actually extended it further, right? So each of those items are called a node, right? As I mentioned to you, a node can be a root node that you can attach, like for example, the event handlers as well as the controller to it, right? So that's why you need to know some of the equivalences, because if you don't know the equivalence, you won't be able to actually convert from one particular Java programming language to another, right? Like for example, from Swing to FX, all right? So you need to know the equivalence. And then in our Swing, we have layout managers, for example, the flow layout, grid layout, and so on. But in our JavaFX, the layout managers are not called managers, but they are called layout panes. And you have the VBox, HBox, grid pane, okay, and also your flow pane and so on, right? So those are called panes. And then in terms of control, in our Java Swing, right, it's called J component. And then in the traditional AWT, it's called component only, right? So you notice there's a word J in front. That means it's very obvious that it's actually Java Swing. All right. So if you look at Java code, especially, anything that starts with a capital J, most likely it is Swing. All right. And with that in mind, you can see that even the components, right? Okay, the components, J button, of course, this is Swing. And then button is actually used in AWT as well as in your JavaFX. So all these are the controls. So I won't go through them one by one. It's just to show you the equivalence. There are some that has a different name. Like for example, your combo box in your Java Swing is called J combo box, but in your Java AWT is called choice. All right. And then further down the road, of course, we have list view, table view, and it's called JList, JTable respectively in Java Swing, and list and table in our normal AWT. So don't worry about AWT because it's already been superseded by your Java Swing. So therefore, there will be less usage of this particular AWT compared to Java Swing, all right? And of course, whatever that it has here, I think more or less is quite self-explanatory. And what I want to tell you is in terms of the canvas. So the canvas is actually used to draw something, okay? Like in the case of your JavaFX, you can use canvas to draw. Remember that, okay? So canvas is basically one of the nodes that you can use to draw something inside your scene, okay? Inside your scene, remember that. And the same thing, canvas can be used in your so-called AWT. And in our Swing, it's called JPanel. Remember that. I'm going to share this file with you, so you don't have to worry. So this equivalence table, I think, will help you to understand the graphics libraries across the different generation. Okay, so this will basically be quite useful because you notice that sometimes when we do programming, you don't know the equivalence, right? How do I convert from this to another? So over here, in our JavaFX, all the events are handled by event handlers. They don't care whether it's a keyboard or whatever and so on. So all these are event handlers, right? And then in your Spring and AWT, they are handled by action listener that listens to the UI interaction, as well as other listeners such as, let's say, your key listeners, right? Or mouse listeners. So those are monitoring just certain events coming from certain input devices, all right? So anything that happens on the screen, they are called action listener. Anyway, right? So these are the things that you need to know. All right. And I'll share this with all of you so that you know how to differentiate them. And this may be a good candidate for final exam anyway, right? But you don't have to specify all. Maybe you just need to tell us the equivalence in terms of, let's say, the most critical ones: stage, scene graph, node, control, all right? Or even layout. You don't have to memorize all, just some of them, okay? And as long as you can show the equivalence, that means you understand how the layout looks like. All right. So from top down, this is how it looks like. And then of course there will be event handlers and also the drawing panes that you can actually draw something. Okay. All right. So that will be the first part that I want to share with you. And then let's have a look at your. Okay, which one shall I start first? I think I'll start with the tutorial, right? So tutorial first, and then we'll go on to the practical later. All right, so next, let's come back to our Java collections framework, okay? So to illustrate this, of course, it's best to actually start with coding. So I'll start Visual Studio Code, and basically I'll be sharing with you some of the important things, all right? So let's close all the screen. Okay, now let's start by talking about how to write, in this case, a JCF class, okay? I'll call this as JCF, Java Collections Framework, okay? And then in order to use a Java Collections Framework, you need to actually import java.util. Okay, so most of the Java Collections Frameworks libraries, they are all located inside utility. And if you look at all the names, like for example, array lists and so on, they are actually located further down. Okay, so java.util. And then you have array lists, and all those things are the one that you can use. And anything that starts with abstract, those are abstract types, okay, abstract classes that you don't want to use, right? And then of course we have other things like DAG, and so on. All right. So the libraries that we are going to use, for example, over here, we can actually use array list. Okay. Array list as one example. And then I'll illustrate to you how you actually write the program. Remember that you must always have a main method in order to start your program, right? So the main method should be static because there's only one copy, right, in your memory. Static void main. And then we have the string array that's supposed to be passed as the arguments into your main. But anyway, it's going to be left empty here. So first, how do we declare an array list? So take note that all these libraries, especially the Java Collections Framework, they allow you to store something, right? Some objects. And the best part is that it is a data structure that can contain another data structure. Remember that. A data structure that can contain another data structure. So in that sense, it can even be able to store another class, okay, as I will demonstrate to you. So firstly, if we want to store an array list of string, you just need to say array list string, okay, like let's say list, okay, or name list, whatever, okay, we call this as name list, is a new instance of array list, and that's it. Take note that the simplest declaration, of course, you need to have, firstly, a type being associated with the data that you want to store into your array list, okay? And you need to give a name to your array list. And on the right-hand side, in fact, you can actually write this, or if you just omit it, that's fine, right? Remember that as long as you have specified the type in the on the left-hand side, okay, then that should be fine. The right-hand side must match anyway. So therefore, if you don't type, that's fine. Okay, if you don't type it, it's still correct. You can see that, right? Okay, and then this will allow you to declare a name list, which basically is an array list that can contain string. And to add the element to your name list, all you have to do is just say namelist.add. And you can actually add a string type, that means a string element, or you can add to certain position a string element. Okay, so these are the so-called overloaded methods, and you can use some of those. And you can add even to the first or to the last. Okay, so it allows you to add to the head or to the tail in this case for that array list. And in that sense, it's quite flexible. So let's say if I want to add, for example, Steve, and then I add another one. Okay, so let's format it. So if you add a number of duplicated elements, they are allowed. Okay, remember that duplicated elements are allowed. Capital and small letters, they are treated as different. All right, so remember that. And then this is an example, okay, to show to you that you can actually add the elements like this. How do I actually remove the element? Okay, so before we remove the element, let me just talk about the methods that will allow you to access the elements inside your list. Okay, so there are multiple ways you can write a so-called loop that can actually traverse through every element and then print out, like for example, the content. All right, so the traditional way, of course, is to use a for loop, right? You can use a for loop to write your program, and that for loop can be just as simple as for integer I is 0, and then I less than your name list size. That means it's the length of your name list, and then I plus plus. So this is the traditional way by using an index. This is by all means not the best or the most elegant way of doing things, because you notice that now you rely very much on the indexes. Okay, the indexes may be correct and it may be wrong. Okay, the indexes in this case. So like for example here, how do I actually perform a printout? You will do system.out.println, and I can print in this case the name list. Okay, name list.get. I can get the index in this case, right? And then I will be able to actually print out the element from here. Okay, so this is how I actually print out the element. And if you run the program, you can see that the output is basically, okay, Steve Teo, Steve Steve. Okay, so duplicated elements are allowed in this case. Remember that for array list, duplicated elements are allowed, and hence you will have something like this. If you change this to a hash set, for example, a hash set, in fact, sets are unique in the sense that the elements should be unique. All right. So if you change this type instead of using array list, right? Can we use any other libraries provided by Java.youtube, right? So as I mentioned to you, Java Collections Framework, they consist of libraries of commonly used data structures, right? So the commonly used data structures will be like, let's say, array, set, list, queue, and also we have maps, okay? So remember these four primitive types: list, set, queue, map. These are all provided in your Java Collections Framework, so you don't actually have to rewrite your own data structure anymore because it's all provided. And the good thing is you can just use whatever features that they have, okay? So like for example, if let's say you were to change this to, okay, let's change this to hash set, okay? So the moment when you change to hash set, then you got to import the library as usual, right? And you notice that hash set doesn't allow this get statement, okay? So therefore you won't be able to actually get the elements here. And what you can do is, instead of writing a loop like this, okay, let me just comment this out first. There are multiple ways you can actually traverse the for loop, right? In this case, this is the first example, the traditional way. And then you can also have the second method, which I will introduce to you. Okay, the second method is by using what we call as the more advanced for loop. Okay, so the advanced for loop actually allows the list to be specified, and then the iterator in this case just needs to be the individual elements, right? So you can just say, okay, the individual elements are of type string. So I will say this as name for each element called name inside my name list, then I will traverse it. And in that sense, I will be able to print it out. Okay, so I'm just showing you some of the equivalence type, right? The equivalence structure when you write your program. And it's important for you to know, all right, because then you'll be able to actually get the list printed. Okay, so this is another way to actually loop through, as I mentioned to you. All right, so if you look at the second example here, all right, so this can actually be used not just for our array list just now, right? So it also works with your hash set. But with hash set, as I mentioned to you, you can only have non-duplicated items. Agree? So non-duplicated items means that it has to be unique. And if you have two Steve, only one will be printed. Okay? Because it only allows how many elements? 3. Because any duplicates will be prohibited and no error messages will be printed to you anyway. So therefore, you notice that if you use a hash set, then unique values can be inserted into the list in that sense. Okay? So I hope you get the idea. So for set especially, it allows insertion of unique values. Whereas for list, it can be duplicated. All right? So let's see. Okay, if we were to actually declare using list, okay, so I would like to actually show how everything works. So let's say this will be the array list. Okay, and then so this will be called name list 2 instead. Okay, and you might want to actually duplicate all the things that you have done just now and make it into array list name list 2. All right. So the difference is very obvious. Right? For name list 2, you can see all the elements, whereas for name list 1, okay, you will only see those that are unique, right? So once you print this out, then you can see the difference. Very obvious. I will just put a dotted line in between so that you know that this is the separator. Okay, so let's separate it. And when you print out, okay, the first list, we have to go up a bit. Let's run again. The first list consists of 4. The second list consists of just 3. So the second for loop, in fact, is much more convenient to write, right? So you notice that this for loop structure is pretty much easy to learn because firstly, you just need to know that I want to loop through every element. I need to know the type of the element, okay? And these are of type string. So for every element of type string called name in my name list, okay? So it's for something in something. So when you read this particular structure, for bracket, dot dot, so it's for something in something, right? For element in list, in this case, for each element in list, I'm going to loop through it and then I'm going to print something. Right, so once you know this, then it'll be easy for you to actually work out your so-called exercises and so on. So the last one that I want to introduce to you is basically an advanced structure in your so-called JCF library. So this advanced structure, in fact, is even better because now you don't even need to know the type of the element. So here I need to know the element type, right? So since you are declaring the element type on top, so you will know, right? These are of type string, fine, okay? But in case if I want to use the more advanced structures, I could have actually used something like this, which is called a name list dot, okay? And then in order to actually loop through every element, I can use the for each construct. So remember that this for each method allows me to actually loop through the element. Okay, let me just using, in this case, a lambda expression. So let me just leave it blank first. You notice that it shows a red line, right? So it's expecting a consumer angle bracket question mark superstring. So what does that mean? It knows that the type is string, okay? The element type should be string. It knows that. And then over here, we could have used a lambda expression again. And you can use any alphabet to represent the variables in a lambda expression. For example, I can use A, okay? And then over here, my lambda expression will allow me to, let's say, do something like system.out.println A. And you're done. Okay? So remember that this is a structure that is very useful, because now this particular variable that I give a name, I need not know anything about the type. Okay? The type, you can just leave it. And you know that the system has already keep track of that. Over here it says, okay, the type should be a super string. That means it knows that it's a string. So here you give a lambda expression A, right? So that variable A will denote this type. And then I can loop through every element for that type. Okay? So the good thing is like this. And obviously, when you print it out, it prints the same thing, okay? So this will be the lambda example. Okay, so let's see. Will it print the same thing like what you have for your name list? Definitely yes, right? Same thing, but much more simplified, right? So that's the beauty of using lambda expression. The lambda expression can be used freely without knowing the data type. All you have to do is just you know what you want to use. Like for example, for this loop, I want to actually loop through every element and print out the value. That's it. Okay? And the rest will be taken care of by your compiler. Your compiler will know that, okay, I'm expecting each element to be of type string. Okay, when I want to print, I print string, that's fine. If it's, let's say, a double or whatever, any conversion will be automatically implied by your compiler. The compiler will find out, and then it will be able to compile the code successfully in the right format for you. Okay, so remember this structure. So this is a very useful one. We have been using this lambda expression in event handlers before, right? Especially in our graphics, right, where you write event handlers for your JavaFX, right? And this lambda expression can even be extended to data structure, okay? And if you have used some of the advanced SQL languages before, like for example, if you are using C# and so on with SQL commands and so on, you notice that you can also include lambda, okay? Lambda is allowed in modern programming languages. All right, so Java is also a very modern programming language, and hence lambda is allowed in this case. All right, so I hope you get the idea. Okay, so which one is easiest to learn? As you can see, some value, right, a dash bracket, that will be the easiest to use anyway, right? You don't even have to worry about the type, and then it even shortens all this for construct, right? You don't even have to write the for construct, and all you have to do is just say, okay, I'm using name list for each. It knows that it has to loop through every element anyway. And then inside the name list for each, I'm going to pass in the lambda expression that says print for every element, print the value A. In this case, A is referring to name list, right? The names of type string, okay? So hopefully you get the idea. There are 3 ways. In fact, that could be the number 4, okay? Number 4, I leave for the lecture, because inside the lecture, we are talking about iterator. Right? You could have used the iterator to get the beginning and the end, okay? As long as you have that iterator, you could basically be doing the same thing like the for loop, but I don't want to use the for loop, okay? Right? So if you use the for loop, then this structure is not to say not good, but you notice that, well, you're actually looping through every element, okay? So in this particular example, of course, we are assuming that the elements are fixed for every iteration, right? When you loop through every single iteration, then the number is fixed. Like for example, if you have 4 elements, then it will loop through 4 times, right? So what if, let's say you try to remove the elements. In this case, let's say we use namelist2 dot remove, and then I'm going to remove according to the index. Sorry, on my typo here. Okay, so the very first run, you notice that you're going to start with index 0, right? You're going to remove the front element. If you look at namelist2, the front element, Steve, will be removed, right? Capital Steve, right? And then the second time when you loop through, the index is 1. And take note that when you remove one element, what is index 1 now? Okay, initially this is index 0. This is index 1, this is index 2, and this is index 3, right? But when you remove this one, when this is removed, this becomes index 0, this becomes index 1, and this becomes index 2, right? The second time when you try to remove index 1, you're actually removing this one. Dangerous, right? You can see that you're jumping one, okay? In this case, this one survives, right? Tail survives. And you go and delete this. And now your list will become, okay, like this. This one that you delete, this is index 0, and this is index 1. And next time when you try to delete number 2, no index number 2, right? Then you'll stop there. And what is, or what are the remaining items in your list then? That will be the most dangerous thing, okay? So what I want to do is, I would want to actually show the remaining items. After that, then you can appreciate how this problem may arise, right? Because you notice that you allow the removal of item when you're looping, and this is wrong, okay? You know that you're going to create some consistency, or let's say consistency issues, and only in for loop, these kind of things are allowed. If you use the advanced for loop, things like this will not be allowed anyway. It will say there's a concurrency issue, right? An error in that case, and then it will not allow you to proceed. So let's see, what's the output finally? Okay, so let's print the number of elements lastly, okay? Dot size, okay? That will print the size. And you notice that these are the ones left over, right? 2 elements are left over. Okay, let's see, this is a bit too far up, so let me just run it again. Okay, so 2 elements are left. Do you get this? So that's why you may notice that that's a bad idea. You only have 2 elements left. Okay? And first time, when you run through, you notice that the first, these are the 4 elements that you added, okay? When you first remove this one, then whatever that you printed will be still Steve, capital, right? Print, delete. And then next run, you are going to delete this one, so it prints small Steve, and you delete it, right? The index is 1. And next one, the Steve is not really deleted, right? So if you seriously want to see what's going on, let's just comment out the bottom ones first before we proceed, right? So that you know what's going on. And best is we do another looping so that you can see that this thing now is actually something like this. So you are left with Steve inside, right? Okay, so I hope you get the idea. And then that's a bad idea anyway, right? So whatever size that you have, you notice that that will, sorry about this, I actually make a remove, so it shouldn't be. Okay, there you go. Lastly, you are left with these 2 only. Theo, capital, and small letter Steve. As I mentioned to you, these are the 2 leftovers, right? Because it wasn't removed. So the initial one, you remove first time, this one out, second time, this one out, and you're left with only these 2. Right? So that is side effect, right? You notice that inside the loop, the index becomes inconsistent because you are removing items from the list dynamically. Right? So if you try to do this kind of things, okay, if you try to do this kind of things inside your advanced for loop and so on, would allow this thing to happen. Okay? So let's say, okay, this is a for loop on another name list, right? So let's unhide this one, and just to show you how things actually work. All right. So now let's see whether the list contains the same thing. Yes, they both contain the same thing. So now if you try to remove items from the list, what will happen? So if I say name list dot remove, and then I want to remove name, will it allow me to do so? What do you think? So I'm using the name list dot remove to remove an element from my name list. If you try to do this, you get an exception that says concurrent modification exception. So that means inside a for loop, the advanced for loop doesn't allow you to remove anything concurrently while you're looping. Okay? And will that be allowed also in your Lambda? Definitely not. Okay? In your Lambda also, if you try to remove items, it's not going to allow you to do so. All right. So this is important. If let's say it allows you to remove, then your entire list will become inconsistent, right? Because the index keep on changing, right? The index keep on changing, and you are removing items, and that causes you to have a problem. Because the second time when you look back to the for loop again, you are going to face a problem because your index is not pointing to the next element. It could be jumping one, like in the previous example. All right. So then over here, if you try to use namelist.remove again, and then I remove A, okay? So remember, whatever variable names that you use, you have to refer back to the same variable name, okay? Will it allow? Definitely not, right? So definitely not. Let's see, okay, I just hide the previous one so that I can proceed. And in the lambda expression, you notice that immediately after you have printed first one, Steve, it stops because it says that the concurrent modification exception happened because you're trying to remove some elements dynamically while you're looping. Okay, that's not allowed. Remember that. Okay, so that is to maintain consistency of your data. Not to say that this is wrong, but it's basically a so-called runtime error, right? You are creating a runtime error, and the system just reminds you that, okay, it reminds you that you cannot do this. If you try to do this, it's wrong. Okay, awfully wrong for sure. Right, so don't delete any element while you're doing a for loop, okay? This is wrong, unless you want to remove all. And if you want to remove all, fortunately for your so-called Java collections framework, it actually allows you to remove all, okay? Like this. If you want to remove all you have to do is just say remove like this. And if you want to remove specific element, please make sure you remove the specific element. Don't use a for loop to do the removal, okay? If you want to remove all, instead of using a for loop, you can just use the keyword remove all. Okay, got it? So that's important. All right, so I hope I've actually illustrated to you about all these things. And it's important because if you don't know these concepts, then you might be removing the wrong items. Okay, so let's have a look at the tutorial 7 questions again. So over here, the first example is an array list. I think it's very clear that you are using the advanced for loop, right, for each element of type string called name in name list. Then you start to print the individual elements. That's fine. The second one is actually using a hash set using unordered unique elements. So when we say unordered, that means it's not sorted. Okay, the elements are not sorted. And if it's sorted, of course, you will be able to actually add element and it's automatically sorted. Like for example, for 3, okay, for 3 sets and so on. Right, and then over here, if you add elements like 5 and 10, the next element that you want to add, number 5, will not be added because it's a duplicate, right? So when you try to print out, then it will just print 2. So those are sample or simple example. In our coming lecture this evening, in fact, I'm trying to do a recording shortly in the evening. What I'll do is I'll do a recording in the afternoon to basically tell you more about all this advanced Java collections framework, such as, in this case, a map, right? A map allows a pair of values to be associated together. So you're actually storing, in this case, in a hash map, 2 values. One is called the key, the other one is a value, right? So the key is used to uniquely identify your value, right? So it's, in this case, allowing you to do a mapping, right? So just like a lookup table, in this case. Right? So our hash map in this case allows 2 data types to be associated with it. Right? The first one is definitely the key. The second one is the value. Remember that. So don't reverse the sequence, okay? So if you want to keep, like for example, the first one, integer, for example, your number for student, right? Then the next one will be your student name, right? Then you have to reverse this one, okay? And this will be used for name list, for example, okay? So hopefully you get the idea. If you want to store result, for example, for Alice, Bob, and so on, so what you can do is you can just do it this way. String first to store unique names. What I'm afraid is that if you have 2 persons of the same name, you die, right? Because it's expecting this key to be unique, right? What happens if, let's say, you try to add the next, or in this case for our map, right? The map keyword will be put instead of add, okay? Remember that. I will share with you a summary of this Java collections framework shortly. and then the associated methods will be shown to you so that you know how to use them. All right? Okay, so remember that for our hash map, in fact, over here I'm using hash map. You can put elements by elements as long as the names are not, in this case, the keys are not duplicated, right? Alice, Bob is fine. If you put again Alice, it will override, okay? It will override the previous one because it thought that you are trying to actually update the value, all right? So if you have duplicated Alice, there you go, your value will go haywire, right? So if you try to basically duplicate and say Alice is 70, then finally when you try to print out, the grade of Alice is going to be 70. So I'm just going to illustrate up to this point only because the next coming data structures and so on, those are more advanced topics, including map and so on, right? Tree map and so on. So those are the ones that we have not covered, but I'm going to cover them in the lecture, right? So bear with me. So far, any questions about this? So I hope you understand the basic concepts here, and I will be sharing with you an explanation on all the Java collections framework, okay? Summary of list, set, queue, and map. This will be a very useful one because you are given all the features of every one of the JCF component. So whether it's a list, a set, a queue, or a map. So over here, a list can be ordered collection, and it allows duplicate of elements. The methods that you can use with it will be add, get, set, remove, index of. So these are the common ones, all right? And the access method, of course, will be by means of using an index or using a match, right? 100% match of your object, right? Or your whatever data that you store, okay? And then we have set, which is unordered. Then we have queue, which is ordered. So if you want to really store a data that is actually ordered in index, right, in sequence, then you might want to actually use a queue. And for queue example, of course, there will be some listed below, right? So other features are all mentioned here. And during the revision, then I'll tell you what to expect for this particular topic. Because this will be exam topics, okay? Examable topics in your final. So therefore, you need to just know some of the basic idea. So I'm sharing with you all the description and everything here. But anyway, don't worry. In the final exam, before the final exam, in fact, I'm going to tell you precisely how to study for this particular topic. All right? Okay? So hopefully you get the idea about all these things. These are the 4 different categories of Java collections framework that we can actually work on. And many of them actually use methods add, right? Add is very common across except for map, as I mentioned to you, right? Map, use put or get, right? Whereas for our list, set, and queue, you can use add as well as remove, okay? Right? So hope you get the idea. Any questions so far? So that will be what you need to expect for this particular topic. Don't worry. Once we have finished the second part, then we'll be able to actually complete the tutorial, right? And the second part, very unfortunately, right, because our lecture is always on the last day of Friday. Last time, in fact, of Friday. And there's no tutorial class that is actually before this particular lecture. And that creates a problem or burden for us because always we are not able to actually have the lecture before tutorial, right? And hence I cannot be teaching in the tutorial for every session. And it won't be fair because I will be teaching only some tutorial sessions. How about those that are not under me, right? It won't be fair. You get the idea, right? Okay, so therefore, the second half of the tutorial, don't worry, I will do a recording as well. So this coming lecture also, because it's going to span more than 1 hour for sure. So I'll try to cover as much as possible during lecture, but there will be a special recording that's probably about 1.5 hours to actually talk more about this particular JCF, right? Especially on the second half, using map, for example, and then the choice or the rationale of choosing which particular data structure to use. Okay, so that will be our first half, and if there's no question, then I will basically stop the recording. Any questions? Right, so this will be about 39 minutes.